gives me immense pleasure to be here again for my course, Flight Mechanics. I am Dr. Yagya Dutta Dwivedhi, Professor from Institute of Aeronautical Engineering, Department of Aeronautical Engineering, Hyderabad, India. I am in the process of discussion on the question bank, and today I am going to discuss about the cruise performance. We will discuss some questions. Before that, I have discussed about the introduction to flight mechanics. In that, we have discussed about the atmosphere, how to make different layers of atmosphere and all the things we have discussed. Today, we will be discussing in this class about cruise performance, their questions and the answers. So in this, we are going to discuss about the thrust required, power required, minimum drag velocity, thrust to weight ratio, and load weight to weight by area. So differentiate between power producing and the thrust producing engine. Where these types of are suitable, explain with example. So differentiate between power producing and the thrust producing. So power producing, first I will discuss the power producing engine. Most of the aircraft, the propeller driven aircrafts are called power producing engine. In these types of engine, we take efficiency as one of the parameter. So here this efficiency of the propeller, which is always less than 1, mostly it is 0.8 to 0.9. So this will be happen, and in this we have the propeller. This propeller is fixed with the gearbox. This gearbox is attached with the engine. So from engine to gearbox, there is some power loss. From gearbox to the propeller, there is some power loss. Everywhere some power loss is there. So there is efficiency we consider in this case for the power producing. If we talk about the jet producing, jet power, means thrust producing. Thrust producing engines. So in thrust producing engine, what we do is we use the nozzle. So here there will be a combustion chamber, then we have the turbine, here we have the compressor, this compressor, then here we have the nozzle. This will give the thrust. Here we don't consider efficiency because here no gearbox, no any rotating part, only the nozzle is here. This nozzle is, so here it is a thrust producing engines like gas turbine engine, then turbofan engine, ramjet engine. These engines are the thrust producing engine, and your propeller, wherever you have the propeller, those engines are the power producing engines. What are the equations of motion in straight and the level flight? Derive the equation of motion in straight and the level flight and explain each of the term. So if we see here, if aircraft is here, so there is a force, there is a weight W, there is a lift L, there is a thrust, and there is a drag. In this case, if we take vertical forces for steady level flight, we will get the equation L is equal to W, and for horizontal forces, this is the thrust and this is the drag, T is equal to T. So these are the two equations of motion for straight and level flight. We are considering that alpha T is 0 in the same direction as the velocity here, and so in this case, and there is no acceleration. So here the lift is what? Lift is equal to half rho v square CL, and drag is equal to half rho v square CD, where CL is lift coefficient, CD is drag coefficient, weight is equal to mass into gravity, and thrust is equal to force produced by engine. Now describe the importance of thrust required and derive expression for this using analytical method. So thrust required. So we have seen just now that thrust TR, thrust required, is equal to drag. So it is very important parameter, because this, if you see, L is equal to W, T is equal to D. So if T by L is equal to D by W, so T is equal to L by W into so this we can W into D by L or W by L by D. So thrust required, if you want the minimum, so W by L by D should be maximum. So this L by D or CL by CD, both are the same. CL by CD should be maximum. So if I draw the plot between thrust required and the velocity, the plot will come like this. This is the thrust required. This thrust required is directly proportional. It is indicating that how much drag is there on the aircraft. And if you want to find out the minimum drag velocity, this is the velocity where this is the minimum value of the thrust required. This is the tangent, and this is the minimum drag velocity. So this point is very important. If you want to fly for a high range and high endurance, you have to fly the aircraft in such a way that you are flying at speed VMD where TR is minimum. Explain about thrust to weight ratio, wing loading, and the drag polar. So thrust to weight ratio, that is called T by W. So as you have the more thrust, that much your engine is powerful. Engine powerful. If you have more weight, W, then T by W will be reduced. So how to increase? T by W, either decrease W by using light material, or increase thrust by improving engine standard. Next is the wing loading. Wing loading, very important parameter, that is called W by S of the wing. S is the area. So wing loading is the weight of the aircraft per unit area. It is called the wing loading, and it is very important parameter for any. So like VS, we have 2 W by SW divided by rho into CL max. So here W by S. So the wing loading should be as low as possible. So low value of wing loading required. This can happen by increasing wing area or decreasing the weight. Everywhere weight has to be decreased. Then drag polar. Drag polar. We know the total drag CD is equal to CDI, CD naught plus CDI, CD naught plus K CL square. This equation is called the drag polar. This is the relation between the drag and the lift. And this is called the induced drag. And this is called the parasitic drag. So, how these things are important? So, we should have CL by CD maximum. It means CD should be minimum. To have the CD minimum, CD naught also should be minimum and CDI also should be minimum. So, we should make sure that our CD is less and CL is more. So, we will get CL by CD maximum. What do you understand by the cruise performance with the mixed power plant? How this method is different from the individual method. So, cruise performance, if we talk about cruise performance, it is a steady state with no turn, no bank, no pull up. It maintains same altitude for the flight. So it is called the cruise performance. And when we talk the mixed power, it is the combination of the propeller and jet engine. Sometimes we use one jet engine and two propeller engine for the high speed jet engine, and for the normal speed we will convert to the propeller. So it is different because we are using two combination of jet engine as well as the propeller. So due to use of two different types of engine, it is called the mixed power plant cruise. To increase performance of the aircraft and increase range and endurance with economical fuel consumption. So these are the things. So explain minimum drag speed and the minimum power speed and describe these importance in the aircraft performance studies. So minimum drag speed, just now I have drawn, this is the velocity, and this is the thrust required. So if I draw, this is the thrust required. So in this plot, if you see here, here, here and here, here is maximum, then here is, but you will have one point here that is at the tangent. This is the point where we have the TR minimum or PR, both are the same. So minimum drag speed and the minimum power speed, and describe this importance in the aircraft performance study, because this is the minimum drag speed. In this you will see that thrust required is minimum. So if you see here, there is a TA. So this is the speed which is the maximum Vmax. Maximum speed where TA and the TR is the same. If you draw about the power, V and the power, so plot will be like this, thrust will be also like this. So here we will draw the tangent here, from here. This is the minimum power velocity, and this is the minimum PR minimum. So this PR minimum is, the VR minimum is higher. VR minimum power is higher than V minimum drag. So that is the difference between these two. So here classify the different flight regime with neat sketch with reference to the Mach number. So we have three ranges of the Mach number, and so Mach number is what? Mach number is the ratio of the speed of object to the speed of sound. So if the Mach number is 1, it is called the sonic flight. If Mach number is less than 1, it is a subsonic. If M is greater than, it is a supersonic. One more range, if M is between 0.8 to 1.2, then it is called the transonic range. So these are the 4 categories, and these are the 4 categories. And if you see that the configuration of this aircraft, if you are in the subsonic zone, your aircraft will be a typical aircraft with wing, high wing like this, rectangular wing like this. If you are sonic zone, like your passenger aircraft, your wing will be somewhat tapered like this. If you are in the supersonic zone, you will have the delta wing, very sharp. Your wing will be like this, delta wing. So these are the different aircrafts. In this way we can classify. So next question is describe cruise. A cruise is a flight phase that occurs when the aircraft level after a climb to a set altitude and before it begins to descend. Cruising usually consumes the majority of a flight, and this may include changes in heading, direction of flight at a constant air speed. Discuss about range, endurance and specific fuel consumption. Range is defined as the total distance measured with respect to the ground traversed by the airplane on a full tank of fuel. Endurance is defined as the total time that an airplane stays in the air on a full tank of fuel. Specific fuel consumption is defined as the weight of the fuel consumed by the reciprocating engine per unit power per unit of time. Discuss the parameters of Breguet range equation. So we know that ds is equal to minus V infinity by Ct into T into dW. So minus V infinity by Ct into W by T, because we have made it multiplied and divided by the W by T into dW by dW. So this range is equal to W1 to W0, V infinity by Ct, L by D, dW by W. So R is equal to, this is the final equation, which is V infinity by Ct, L by D log W0 by W1. So here we can see the main parameter is L by D. As you have L by D or CL by CD maximum, you will have range also maximum. That is the first point. The second point is your W by W0 means W0 by W1. How much fuel? This is how much fuel your aircraft carries in the board. Third one is the velocity. A certain amount of velocity only, that is called V minimum drag. In that only your aircraft will give the maximum range. So we have to make sure that these parameters are fulfilled to achieve the maximum range of the aircraft. So mathematically, the range for the propeller driven airplane and how it's differ from the jet engine illustrate each term. So we have seen here that R is equal to V infinity by Ct into L by D log W0 by W1. We can make it in the terms of the propeller here. Neta propeller, that is the efficiency. CV0 into V0 L by D log W0 by W1. R is equal to NPR by C L by D log W. So here also L by D is important. NPR is here efficient. As much you have more number, R will be more. So you have to fly at a maximum L by D. That is the first one. Have the highest possible propeller efficiency. NPR should be as much as possible. Have the lowest possible specific fuel consumption. C should be less. Specific fuel consumption should be less. Have the highest possible ratio of the gross weight to the empty weight. It means W0 by W1. It should be high. Means fuel consumption, fuel quantity should be high. So apply and demonstrate the propeller driven range equation, Breguet formula. R is equal to N by SFC, CL by CD, log W initial by W final. Here we have the maximum range, largest propeller efficiency, lowest possible SFC, highest ratio, largest weight, fly at a maximum L by D. These are the parameters. R is equal to N by SFC, CL by CD log W initial by W final. Here we have, this is the propulsion, this is the aerodynamics, and this is the structures. Explain the total airplane drag types, drag reduction methods. So we have basically two types of drag. One is the parasite drag, another is the induced drag. In parasite drag, we have the skin friction. In skin friction drag, then we have the interference. In induced drag, we have the lift dependent drag. Then we have the wave drag. This drag is due to the This drag is due to the Mach number or due to sonic range. And this drag reduction methods, we have VG, vortex generator, winglets, riblets like shark and all, winglet like bird, aircraft. VG also used in aircraft. Now, average value endurance equation. So, we have to see that average value equation is SE W0 minus W1 1 by T SFC TR W0 minus W1. This is called the average value endurance equation. W0 is the aircraft initial weight and W1 is the final weight. The equation says that endurance is improved by maximizing availability of the fuel, minimizing both thrust specific fuel consumption and thrust required for drag. This makes sense. Sometimes the equation is written in the following form, particularly if thrust curves are available. So these are the equations which gives the. So in the next, these are my references: aircraft performance and the design, then international edition McGraw-Hill's first edition, SL by ME aircraft performance theory and practice AI education series. Any questions you can ask to me in this ydwivedi@gmail.com. Please do like and subscribe my channel. Till then, goodbye and thank you.
Like, share and subscribe. Hit the bell icon for more updates.